Good morning, everyone. Thank you very much for coming. Up next, we have Stuart Herbert. He's originally from Yorkshire. He studied at the University of Sheffield, but now lives in South Wales.
Indeed.
Okay. He's a software engineer, a technical leader, and a manager. He's written for PHP Architect. He's the co-author of the official Zend certification study guide for PHP 4. Be kind. Stu's going to talk to us about creating pluggable pipelines with the instruction bus. So please give a very warm welcome to Stuart Herbert.
Good morning, everyone. Thank you all for coming. I must say, it's wonderful to be able to come to Yorkshire and speak. So I'm going to talk to you today about middleware. And what I'm going to do is I'm going to show you how to build a middleware pipeline for your specs. So this isn't a PSR-7 talk. PSR-7 is a specific case of this. Well, what we're going to do is we're going to build a real-life pipeline. I find it's the best way to show people how to do this sort of thing. So we're going to go through the full design process, we're going to write some code, and we're going to do the testing. 45 minutes, give or take, if I don't breathe. Okay? Now, this is made possible by an open source library. It's available up on GitHub and on Packagist. And if the Wi-Fi holds up, the library we're going to build in this talk is already up there as well. So you should be able to read along online. I'm promised that the Wi-Fi will hold up for everybody. So we'll see. Now, to get started then, what's a pipeline? Anybody in the room, how would you provide a definition for a pipeline? Anybody? Cat.
Something that transfers something through something to another place.
Okay. Okay. That's a pretty good one. Anybody else? I saw another hand.
Like in a factory where you move something along, do something, move to the next bit, something else.
Okay. So there's a common theme there of moving data from one thing to the next. There was a hand up at the back. I'm sorry, you're silhouetted by the door being open, so I can't see you. Okay. Yep. So there's a key point there about things being done in an order. So let's break that down and look through it. First thing about a pipeline is it's built from isolated modules. We have a collection of modules that don't know about each other. And we assemble them. The person using the pipeline decides which modules to use. And we put them into an order. And as has been said by everybody in the audience, we then push data along it. We take that data and we put it through those modules. Now, pipelines are ordered. They are deterministic. And if the modules inside the pipeline are written in a deterministic manner, it makes them very easy to test, very easy to debug, hassle-free. And it's important to remember that we, the person using the pipeline, we decide the order of the modules, not the person who's built the pipeline. And that gives us a lot of flexibility, which we'll see highlighted throughout the talk. Because it allows us to respond rapidly to change. And there's going to be some examples of that. So what can we change? First thing we can do is we can change the order of modules on the pipeline. We can take a module and we can move it. Very easy to do. We can decide which modules are in the pipeline. If requirements change, we can change which modules are there. We can take a module, we can replace it, or we can get rid of it entirely. It's up to us. And the key thing about this is we can do this without having to touch any of the other modules whatsoever. We don't have to change any code. And the more in a project you can reduce the footprint, the size of change in a project, the less bugs you're going to introduce and ship when you ship your new features. And another powerful thing about this is pipelines are often defined in config rather than in code, which again means there's less for you to open up to have to change. And here's an example of some config. I hope everyone can read that. We'll be going through this in a lot more detail in a moment. Now, people mentioned about pipelines handle data. What do you think happens to that data? How would you describe the operations that are done to that data, anybody? Transformed. Okay. Yep. Any other things? Monitored. Interesting. Okay. Anything else? Cached. Okay. So there's three things we talk about with pipelines, what they do to data. They modify data. You take a string, you add some more data to it, and we'll be showing some of that in a moment. You transform it. You change its data type. You change it from an integer to a string, change one object to another object. Pipelines can also reject data. If anyone's played with PSR-7 middleware, one of the common things people do with that is they stick a little firewall module in their pipelines to reject certain IP addresses if they're not able to configure the web server for themselves. No, not. Sometimes a developer doesn't have access to that production environment, and the only way they can do these things is by shipping code, because they can't ship config to change the web server. It's not a skill thing. In larger organizations, it's a demarcation line thing. Not everyone operates DevOps, and DevOps these days often means sysadmin. The dev part of it gets left behind. I've seen that happen so many times. Now, I said this isn't to talk about PSR-7. There's two mentions of PSR-7. This is the first of the two. PSR-7 middleware is an example of a data transformation pipeline. It turns HTTP requests into HTTP responses. But what we are interested in, and what this talk is about, is how to take the concept of a pipeline and use it for your own business needs, or your own organization needs, what your app needs. Because we're a very, very flexible, very powerful architecture pattern. Okay. So let's get into building one. And I think it helps if we, rather than explain how the library works, for you to build libraries, let's actually build a library. And let's use a real-life use case, which is message queues in the cloud. And the situation I'm thinking of here, you've got a public web server, public web app of some kind, and it's got a REST API to a back office. That might be one monolith. It might be a set of microservices. Doesn't matter. You've got a user there talking to the public web server, but they're not allowed to interact directly with the back office service. Now, more and more, we need our back office services to tell the public web app asynchronously about things that have happened. My use case for this was a payment system handling millions of pounds of payments a year. And we needed to tell the web server, the public app that was using our payment service, when things had happened at the bank. Now, because they're asynchronous, a message queue is a great solution for this. Other options are available, but message queues are a great solution for this. And most cloud environments come with a message queue solution of some kind, so you don't have to roll your own. Which led to the first design constraint for this library. Got to use the cloud provider's message queuing system. They're very good at running infrastructure, and they should be doing a better job at keeping infrastructure up than you are. And the whole point of using the cloud is to reduce the amount of things you have to maintain, so you can focus on what adds value to your business rather than doing what everyone else is doing. Now, the thing is, any infrastructure from a cloud provider is an important principle, and it's easily forgotten. You have to assume it's a third-party system and it's untrusted. And for the payment system where this example comes from, this meant we had to make sure the data was properly secured. Now, the message queue was accessed over HTTPS, which is great. That's encrypted. HTTPS is considered secure at the minute, provided you don't buy your certificates from certain companies, naming no names, semantic. So that's great. And for a long time on our project, we were thinking that's all we needed to do. But then we had a look at what happens when the messages are inside the queue. The cloud provider wouldn't guarantee that they were encrypted. It was a black box to us. It wasn't documented. We didn't know what was going on. So that became our first requirement. We needed to encrypt messages before we sent them to the queue. If you're using two-way encryption, it's a good idea to sign the messages to detect tampering. It's a third-party system. We can't see what goes on there. We've got no monitoring inside the system at all. All we can do is add our own little canaries to tell if anything's been changed. Hashed Message Authentication Code, HMAC. Anyone played with HMACs before? A few? Okay. It's functionality built into PHP. It's easy to access. Now, the message queue had another consequence as well. You can't throw blobs at it, this particular message queue. If anyone's wondering, I'm talking about Amazon's SQS. It only accepts 7-bit ASCII. So we also need to transform our data and make sure it's safe before we send it to SQS, because the last thing we want is a payment status change to not reach the front end because the queuing system's rejected the message. So we need to take our encryption, our HMAC, and we need to make sure the final output is 7-bit ASCII. Now we had a second constraint. Both systems were written in PHP, but we knew that might not always be the case. So it was important the contents of the message were readable in multiple programming languages, just in case. So that means PHP serialize is out the window. My personal opinion is you should never use PHP serialize ever, anyway. It's the wrong solution for practically every problem out there, especially if your data is actually going to be stored at rest. So we needed to add some sort of data transformation. And JSON's the go-to one. Others are available, but JSON just works everywhere and saves you a lot of hassle. Now, in our real-life scenario, encryption wasn't the first requirement we identified. We didn't know that the cloud provider definitely didn't do encryption until quite late in the day. So we started off just with JSON and 7-bit ASCII. But we actually had built a pipeline. Even though this seems quite simple, quite trivial, we actually built a pipeline. We knew our customer would have new requirements in the future. Those requirements might be a different queuing system. And at that point, we needed to make sure we could change things very quickly. But because we'd used a pipeline, adding in the encryption was very straightforward. All we had to do was create the new modules, put them in. The code we'd already written and shipped to test and shipped to the team that was writing the front-end app didn't have to change at all, not once. And it also meant that the pipeline deployment hardly ever changed at all. All we had to do was extend our Puppet scripts to generate the extra config for these extra modules. So pipelines give you a lot of benefits, even for what seems like a trivial problem, even something that seems like a 4-line PHP script. You get a lot of flexibility in larger projects if you adopt a pipeline model. And what I'm trying to show you here is how the design of your pipeline, the things that your pipeline needs to do, should be driven by your requirements. Don't build ivory towers and wait for problems to come to you. Solve the problems your organization or your customers have. Okay, so everyone with me so far? Right. So let's break down these requirements and show you how to implement them. We've identified the 4 things we need to do. But this isn't the code that runs inside the pipeline. This is still quite high-level stuff. What we've identified here, I'm going to use the term instruction builders. This is a pipeline that runs instructions. And what they are, these are the factories we need to build to create the code that runs inside our pipelines. And that's all an instruction builder is. They're factories. Hopefully you're all using frameworks that use dependency injection, inversion of control, so you're all familiar with factories. How many of you like factories? Hardly any hands. Okay. They're worth the hassle, I promise. And the factories instantiate objects we call instructions, and they are what runs inside the pipeline. And make your instructions as small as possible so it's easy to move modules around on the pipeline. And I'll show you that in a moment. So here's our instruction builders. And here's the set of instructions they generate. Not quite. This is a message queue system. There's a transmit and a receive. So we need 2 queues. And this is where your factories start to add value. Because you need to not only be able to turn something into JSON, you've got to be able to turn it back from JSON. You've got to make it 7-bit ASCII safe. You've got to decode it back into 8-bit binary. You need to encrypt. You need to decrypt if you're using 2-way encryption rather than public-private key. If you're using a HMAC, not only have you got to add one, you've got to make sure your message hasn't been tampered with, and then you've got to remove it from the message as well, because nothing else is expecting that HMAC to be there. You need 2 pipelines. And that's the other value that these factories add. They know how to build both pipelines from one factory. If your problem only needs one pipeline, you can do that too. And PSR-7 is an example of a unidirectional pipeline. You don't have a transmit and receive pipeline in PSR-7. But in my experience, a lot of my pipelines I build for my customers do need both. So let's fill out this table. Here's our list of instruction builders, our factories. For JSON, it's really straightforward what we do. And it's easy to fill this out for everything else. There's always two instructions, for every module we've identified. A forward and a reverse, how we do something and how we reverse what it's done. So far, what we've done is we've worked out the individual instructions that we need to code up. So let's do a show of hands. At this point, how many of you would jump into code? Do you think we're ready to do so? Okay. Nobody thinks we are. So what do you think we need to do? We've worked out the operations. They're all very simple, very straightforward PHP operations. Most of these is 1 or 2 lines of code. So what do you think's missing? Anybody? Tests? Okay. So you're proposing something like a TDD type approach, test-driven development. Over coffee. Anybody else? Not defined the boundaries between components. Okay, that's interesting. Anybody else? Interface for the pipeline. We do need an interface for the pipeline, but we're going to come to that later on, because you can get away without the interface for a lot of things, you'll see. We use the interfaces for type safety and type declarations. We've got a couple of slides on that towards the end of the talk. Okay. What we haven't done is decompose these down into more reusable code. We can break these instructions down. And the reason for that is you should treat your instructions like you're supposed to treat your MVC controllers. Who here does thin controllers and fat models? A few hands. And who does fat controllers? Most people don't want to admit it from the body language. You want your instructions to be thin, and I'll show you why as we build the code up. So if we take our instructions, we're going to focus on the HMAC stuff, as it's all the things I want to show you occur in the HMAC operations that we're going to go through. So let's decompose that down. To add a HMAC to a pipeline message, I'll do this one for you. We need to calculate a HMAC, and we need to add it to the existing message. It's 2 separate operations we need to do. On the receiving end, when we've got a message with a HMAC attached, what do we need to do to verify that the HMAC's correct? How would you break that down, anybody? Calculate, compare, okay. Anybody else? Anything else? You're a tough crowd today. You really are. Okay, so we've actually got to make sure there's a HMAC there in the first place. It's perfectly possible we'll get a message off the queue that doesn't have a HMAC at all. We actually need to remove the HMAC as well, because the rest of the pipeline is not expecting the HMAC to be attached. And as Rob said, we need to calculate it and compare it and verify it. Now, one of the reasons for breaking this down is we've already started to identify repeated pieces of code. And we don't want to duplicate this code. We want to keep our code quite dry. I am changing my advice here from the PHP 5 days. In PHP 5, I would repeat code rather than separate it out into extra functions and methods, because the overhead of calling functions and methods in PHP 5 was horrendous. PHP 7 is much more friendly for your CPU instruction cache. And if you're running Intel servers in data center, or you're using the cloud, which runs 99% or something on Intel, your chances are you're running on CPUs where cache-friendly code is very important. And so building small methods that get called repeatedly, you get a performance benefit from it in PHP 7 you never got in PHP 5. That's one of the reasons it's important to break code down to this level these days. So our operations, there's another term here, they're the smallest units of work that it makes sense to reuse. And we're going to reuse all these operations we've just defined. Now, Jeremy was talking about boundaries. Here's our first boundary, is these individual operations do not know that they are running inside a pipeline at all. They have no knowledge of it whatsoever. They're just there to do one job and do it well, and that's it. Which makes them very easy to code, very easy to test. So now we're ready to get into some code. And let's hope this is readable by everybody. Can you all read that? Oh, thank God for that. It's been years since, I think, 2008, Jeremy's conference, may have been the last time I put code up on a slide. So I'm not very practiced at this bit of speaking. Right, so here's calculating a HMAC. We make sure we've got a HMAC algorithm that the PHP supports. You have to check that at runtime because it depends on your compiled copy of PHP. And then we compile it and we return the HMAC. That's all we do to calculate a HMAC. It's that simple. It's 2 lines of code. To add a HMAC, we reuse the calculation and we prepend it to the payload, our message. That's it. It's very straightforward. On the receive pipeline, when we're looking for our HMAC, we go hunting for a marker to split the string in half. If we don't find it, we throw an exception. And this is something very important about decomposing code down to this point. This is the code that knows whether or not there's a problem with the data that's being handled. So this is the best place to do your error detection. And we'll see the consequences of that as we scale the code up. If we find a HMAC, we return it. We return the position of the marker. To remove the HMAC, we go find the marker, and you'll notice there's no error checking there whatsoever. Because we're doing error checking at the lowest possible level each and every time, code that calls it can assume that everything's fine and works. You don't need to do error checking. Exceptions will do it all for you. So we can write this code in perfect safety. We know if we've got a marker position, we know we actually have something that we believe could be a HMAC. So we can run that, and we're not going to have any problems. We don't have to worry about the way PHP converts things to 0. Don't have to worry about that at all. And for verifying, we reuse the calculation operation, and we do the compare. And again, we throw in error if there's a problem. So we're detecting errors and making sure they can't propagate. Now, you're all looking very bored, and I'm not surprised, because this code's boring. It's very simple. It's very straightforward. There's no magic to it whatsoever. But in my experience, in my career, this kind of code will run for years. Your big problem will be when PHP no longer supports the hashing algorithms you want to use. PHP breaks backwards compatibility. Or you're running on a platform where some of these algorithms have been compiled out. That'll be your problem. It won't be this code. This code will just run for years. The code very similar to this has been in production at least 12 months now. I'm not even there to maintain it anymore. That is no longer my customer. It just works. So unfortunately, boring code makes for an easy life. So we've identified our operations, and we've built them out. And now we've done that, we're now ready to go up a level and work on our instructions. And the nice thing about these operations is they're ready to run. There's nothing else you need to do. You can write your unit tests right now. And if you do your unit tests at the end of your project, you can go ahead and move straight onto your instructions. So let's go and do that. I am going to cover unit testing, but I've put it in a section at the end rather than scatter it throughout the project. Now, aggregation versus inheritance. How many of you know what that means? A few people. Okay. So instructions aggregate our operations. They call our operations. We're not extending classes there. And the reason for that is in OOP, you aggregate to get the maximum amount of reuse. Inheritance is best for specialization. And one of the reasons I've picked the HMAC stuff is because we're about to see both of those in action. So here's the instruction to sign a payload on our transmit pipeline. And it's extending a base class. We've got some setup to do about the HMAC algorithm for both the transmit pipeline and the receive pipeline. So that's gone in a base class, which we're going to specialize, so we don't duplicate it in our instructions. And the code to actually add the payload is very simple. We just call the operation. We modify our payload. And then we pass it on to the next instruction in the pipeline. We don't know what the next instruction is. We're told what the next instruction is. It's passed into us as one of the parameters to the methods. And unlike something like PSR-7, Slim, Stack PHP, we actually take the instruction as the first parameter, not the last. The reason for that, PHP 5.6, I believe it was, the 3 dots operator, The coalescence, is that a coalescence operator? No? Okay. But what it allows you to do is the underlying library can just take all the other parameters and put them all into an array to make it easy to pass around. And by putting an instruction at the front, it makes life a lot easier for that. So that's why it's at the front. And you can go into the instruction pipeline library and see how that works. I'm not going to go into that any further today. To verify the payload, we go and remove the HMAC. We extract it out, so we've got a message and the HMAC we've received. And then we verify it. And once again, we pass it on to the next instruction. That's it. You'll notice in both of those, there's no error handling needed whatsoever. Absolutely none. Very thin code. We know that the operations, well, if they detect any problems, they're going to throw an exception. And they're able to throw a very specific exception. I've worked with frameworks in the past where everything was a runtime exception. And the only thing different was the contents of the message, which makes writing robust code impossible. You don't know what errors happen, so you can't recover from it. This approach means at least you know what the error is. You may not be able to recover from it, but at least that's down to the individual error that's happened rather than the framework design. Let's look at our base class for a moment. And I mentioned here about specialization. So I'm a great believer that your base classes should probably be abstract as much as possible. And because the reason here is what we're providing as a constructor to do the setup. We're making sure the HMAC algorithm and our passphrase that we're using to run through the algorithm are both in the config we've been provided. And we just stash that for our child classes to use. That's all we're doing. We're not providing a default behavior for when the code's called on the pipeline. We're just doing the setup code. So that means we have to provide the abstract function. And that defines the type signature for both the receive and transmit and receive pipelines, for HMAC as a result. Now, I apologize if I'm laboring this point, but I'm trying to get across is this approach means you've got a lot of power with very little amount of code because of the levels of reuse. They're very lean, they're very clean, they're very easy to maintain, they're very easy for a lot of people to work on. You don't have to have your senior developers doing everything all the time. But we can't run these yet. I mentioned there's a next instruction, and we need to get into that. So let's talk about it. And the other thing about next instruction is if you understand how this works, you understand how all these pipelines work. Not just what I'm showing you today, you understand how Stack works, you understand how Slim pipelines will work, you understand how Zend stuff works. They all work in a very similar manner. So we've got our instructions, and when we create a pipeline, they go inside a container. Next instruction is actually the container that holds the list of instructions. And when you run the pipeline, you actually call next instructions process method to start it off. And it goes and looks at its list and goes, okay, we're at first item in the list, let's go and call that. Our instruction runs, and as you've seen, it calls the process method, which comes back into our container. And it goes, okay, now we've got something else. We're on to item number 2 in the list. Let's go and call that. And so on and so on and so on. Calling your instruction, it calls back into the container. None of these methods have exited yet. You're building up a call stack until you get to the very end. And process in the container goes, oh, that's it. I've run all my instructions. There's nothing to do. At that point, it returns whatever the last module sent to it. That's what it does. Which means we then start to unwind the stack. We've got a return value that has to flow back through all these methods that have been called. And that's what happens until eventually you get to the last module, it's returning, and then we return. That's how all these pipelines work. They all work in the same manner. They have different terms for things. The new PSR standard that's coming underway, I believe, calls these delegates, if memory serves. But they all work fundamentally the same way. Here's what our next instruction class looks like. This is the entire class. That's it. It's got one method on it, which is our process method. And the reason it's so small is because we're now starting to make use of the underlying framework that I've built to make all this possible. And that's up on GitHub. It's up on packages. You can pull it down. I will confess, there's no documentation for it yet. There will be next week. But this talk will give you enough to be able to use it straight away. And of course, we're giving you a full production-ready library that you can take away and examine as well to see how to use it. So the underlying library provides the container, the next instruction list container. And all we do is specialize. We extend it, and we define what our signature should be for our process method. That's all we do. That's all we need to do. There's some benefits to this, and I've got a section more on type safety towards the end of the talk to go into that in more detail. But for now, you have to build this wrapper. But it's very quick. It takes 5 minutes to build. It's not a problem. So we've built our instructions. So the next thing we want to do now is build out the factories, because now the instructions will run. So if we were doing so, we could write our unit tests at this point. And I'll show you those later on. But I want to focus on the factory. Okay. So I've said the factory goes away and builds 2 instructions, 1 for each pipeline. Once again, it's a very, very small piece of code, because once again, our underlying library provides us with some help. There's a generic instruction builder in the underlying library that we can pull in, and all we have to do is tell it for each pipeline which class we want to instantiate, where our instructions are. That's all we have to do. The underlying library is deliberately very generic, so it has a forward pipeline and a reverse pipeline. That's the transmit pipeline and the receive pipeline for messaging. The generic instruction builder expects you to pass a single config array into the constructor for each of these instructions. That's because most of the modern frameworks, the DI container will have some sort of config object in there that you pull out, and it's an array, and you just pull out the bits you need. So it's meant to be easy to drop into your projects. So if we go back to our HMAC class, our base class, we can see here, we take the array, we make sure it's got the keys we're expecting. We don't need to validate the values, because we know our operations will validate those when they're used. We don't need to validate them at this point. It's unnecessary duplication. If you feel strongly that you should be validating as close to your config as possible, write a config linter for your project. Do the validation there. And that way you've got a tool that you can run in your deployment scripts, in your Puppet scripts, Ansible, Salt, whatever you use, so that you can make sure you haven't deployed a bad config. Do it there. Do it right at the edge. Don't do it here in the middle. There's no point in doing that. It has no value. So here's our config. Here's what it looks like. We say which class we want for each of our instruction builders, and we tell it what the config is. We just pass an array in. That's it. That's all we have to do to define our pipeline, our list of instructions. Very simple. It's very easy to put together, and you can see here, all you've got to do is move these lines around if you want to change what's in your pipeline. That's all you've got to do. So that's how we do our factories. And to build out the rest of the library, you follow the same process. Define your operations, build them out, write your instructions to call your operations, and then finally call your factories, build your factories, and call those to complete the library. And if you do that process all the way through, you'll find that very quickly you can build out a whole pipeline library. This library that's up on GitHub was built in about 16 hours, start to finish. You can probably check the Git logs to see whether that's accurate or not. You'll also see that the first commit was probably Monday morning. So obviously the first version of this was built for a customer. It's their IP, so I've built a generic version for us to all have and share. But how do we execute all this? How do we actually create a runnable pipeline now we've got this all together? There's one last helper we want to build. And this, I promise this is the smallest font you'll see on my slides. It just about fits on the screen. It looks great here. Doesn't help anybody else. But let's break this down. So, once again, the underlying library provides us with a tool to build pipelines, and we're specializing, we're extending that. And the reason we're specializing is we want the underlying library to know what our next instruction wrapper is. And that's what we do. We pass that in. We specialize. You don't have to do this if you're happy to use the underlying libraries container and you don't care about signatures, etc. You can just use that and avoid these wrappers. But if you want type safety, this is the way to do it. And here's the wrapper class. It's actually one of the parameters. It's part of the signature of the from method. Now, I've been talking about transmit and receive pipelines, and I mentioned that the underlying library knows those as forward and reverse. So we could just define aliases as constants for this. I'm a great believer in aligning your project, your business language across your functions. So if you're working with a message queue, transmit and receive is a more natural language than forward and reverse. So just put an alias in there, and then make it so people don't have to think about the things they shouldn't need to think about. Just make it easy for people. That's it. That's the code. That's all you need to do. To break that down, we've built the whole library as a total of 11 operations, including the base classes. There's 10 instructions, including base classes. 4 factories, 4 instruction builders. To make all that work, we're supporting those with 8 robustness helpers, broken up into checks and requirements. There's a total of 11 exceptions that can be thrown, including interfaces and base classes. And there's 2 type safety instances, which we haven't mentioned yet, but we're going to go into in a moment, to help us enforce type safety across the pipeline. Like I say, that took me about 16 hours from start to finish to build. It's very easy to knock out these pipelines once you know how to do them. And if we put it all together, I'm going to show you now an example of what it looks like to run these. This doesn't fit on one page, so I've broken it up into 2. The first bit is we want to emulate the config, how it would appear in your DI solution, in your DI container. So we're emulating the config. Specifying your encryption, specifying a key, and a secret as well. That's the initialization vector for those familiar with the OpenSSL language. Because we're using two-way encryption and because message queues guarantee no order of delivery or delivery at all, you can't use the normal trick of your initialization vector being based on the previous message, because you can't have that ordering in place. So you end up with a static initialization vector. There are people in the room who know more about this stuff than me. Go talk to them about it, if they'll admit it. This works. This is good enough for government work. We've seen this snippet on a couple of slides. Here it is in context. Here's our list of instructions. To build the pipeline, we just call our helper to build our pipelines, and we get back an array with 2 pipelines in. And to prove this is working, we're going to take a piece of PHP data. I'm going to var dump it to the screen in a moment so you can see that it's definitely doing something honest. And then we call our transmit pipeline. We pass the original data in, and out we get a message. It's really trivial to use. There's no magic needed at all. And then afterwards, we reverse that message, and hopefully we're going to get the original data back. Let's find out, shall we? This is what it looks like. Way that works. So here's our original var dump. This string here is our 7-bit ASCII. Yes, it's base 64 encoded. No, base 64 encoded is not encryption. The encryption's inside here as binary data. Some of you in the room will know you can tell OpenSSL to output more than just raw binary. You can put wrappers around it. Some of that's documented, some of that isn't. I'm a believer that you're better off producing binary data out so that you've got control over the output format. Make that a separate module in case you need it, feed it into different endpoint systems. If you build all that into your encrypt module and your requirements change, you have to open up your encrypt module to change your total output, and that goes against the philosophy of a pipeline. And finally here, we've got our original data back where we dumped the received data. So it does work, honest. You can download the code, you can run it for yourselves. This code is in the examples folder up on GitHub. So you don't have to take my word for it, you can go and run it for yourselves. And if you get anything different, I'll be in the pub. Okay, so to summarize, here's our build order when you're building a pipeline once you've done your decomposition. Build your operations, Build the next instruction and the build helper next, because that makes it possible for you to test your instructions once you've built them. Build your instructions, build your factories, your instruction builders. And that's how you build a pipeline. And the thing is with this is you decide what goes on the pipeline. You decide what your payload is. You can pass multiple payloads in. You can have a pipeline that's got 2, 3, 4, 5 parameters in. I've used this for a data product for my current customer. And I think that has 6 parameters we're passing around in our pipeline to keep track of things in order to make the data product work. It's very flexible. You're limited only by your own requirements. Everyone happy with that so far? What do you think to it? Is it interesting? Nobody's left yet, but I think that's because it's a long walk down to the front. Okay. We're almost done. I want to talk about type safety, and I promise to talk about unit testing as well before we finish. They're both very important. So why am I talking about type safety? Those of you who like to follow online drama in our community may be aware that PSR-7 isn't universally loved. Okay? You may be aware that there are people in our community who have been very concerned about the design of middleware built around PSR-7 because you can't enforce type safety easily with it. And for those of you who are not familiar, those of you who are not yet using PHP 7, what I'm talking about is being able to switch on strict type enforcement in PHP 7. There are also people in our community who believe this solves all your problems. You never have to write a test ever again. I have a slide for them too. I fall somewhere in the middle just to do that. Right. So types. Here's my take on types. They're a kind of policy. If you're building a generic library like the instruction pipeline library that we've seen in some of the slides, its job is not to enforce type safety on you. Your code, which in this case would be our messaging pipeline, that's where the type safety goes because that's where you set policy. This is an old Unix philosophy. This has been around decades. Those of you who aren't running Windows, in fact, quite a bit of the Windows subsystem as well, is all built on this fundamental approach. It's one of the things baked in. It's what makes all of our software work. Because otherwise, you end up not being able to reuse underlying libraries. So what do you think? How hard do you expect it to be to add type declarations to our library? Who thinks it's going to be really easy? Show of hands, please. Who thinks it's going to be really easy? A few people? Who thinks it's going to be relatively easy with a few gotchas? Okay, a few more hands, including some that went up before. And who thinks it's going to be an absolute nightmare and a ball ache? Nobody thinks it's going to be terrible. Well, that's good. Well, let's break that down. Right, so operations. They're boring. They're really boring. And then when it comes to type safety, they're equally boring. There's no problems whatsoever doing type safety with your operations because there's no magic going on there whatsoever. So here we have our calculate HMAC. And you can see it's got all the types there. It's got a return type. Every input is typed. Not a problem whatsoever. And for all the operations, it's exactly this easy. Because they don't care. They don't know about the context they're running in. They don't care. They get to define what they accept. They're in charge of that. So at the very lowest level, we've got type safety baked in. There are absolutely no problems with doing that whatsoever. Instructions. That's where the gotchas can come in, because it depends on what your pipeline does. I mentioned earlier that pipelines transform data, and these transformations are where you're changing the data type of your payload. And when you change the data type, you have to change the signature of the methods that are being called. And we'll show you that in a moment. Pipelines, generic pipelines like these, your instructions don't know about any of the other instructions on there. See, PSR-7 is an extremely specific case. It's got one signature for everything, and they all have to do the same thing. They all have to accept a request input. They all have to produce a HTTP response output, which isn't always what you want. What I do in my code, I have a PSR-7 middleware pipeline to get the HTTP request. When I break it down and actually call several of these type of pipelines to do the real work in order to generate a return value. And it's your return, sorry, let me take a step back. I showed you how the next instruction works, the container, how the call stack builds up, and how the return value has to flow back through everything. And that is the main limitation with these style of pipelines, because it's returning whatever the last instruction on the pipeline decided was going to be the output type. And if we turn that into a table to try and show what I mean, we can see here our JSON module can take anything and turn it into a string. You can't, in PHP-7, the types are quite limited. You can't say, I'll only take something that can be converted into JSON. There is no such type. You can take an array, you can take an object. Because PHP extends the JSON standard with its own things, it will also take strings, it will take numbers as well. So we have to say it takes mixed as a result, and outputs a string. And the rest of the pipeline's fine, it's all strings. But our reverse pipeline, which you have to read bottom to top, obviously we're reversing this, and ultimately we produce a mixed, which makes type safety on this type of pipeline quite limited. But where we can know what's going on, like these here, string to string, we can define interfaces for these in order to do our type safety. And I'll show you this. We'll start off with the JSON module, and I'll show you how this works. So here's our JSON instruction to turn a PHP variable into some JSON. And we've defined an interface. I've called it mixed in, mixed out. In-out, I find, is the best way to express these type interfaces. And all it does is it types the invoke method. Or rather, it doesn't type the invoke method because we don't know what we're going to get out. And we can accept anything. So we can't do any type hinting here. This has to be generic. We can type hint our instruction. And we're going to talk about a bit more of that with type safety in a moment. But our payload at this point could be anything. And although our pipeline at the minute returns a string at the end, if we extend this pipeline to something, when we replace SQS with something else, we might not be sending a string out to the message queue. We may be having to create an object because the SDK for a different message queue may expect an object. It may not accept a string. So we can't say that this is definitely going to return a string. So we have to leave it untyped as well. And this is where the gotchas are. If we go to our HMAC and look at that, here we can be tight on this, or tighter. We can't process, if the input's not a string, it can't work. Absolutely can't work. The algorithms can't work. So here, we can use a different interface, string in, mixed out. And all it does is define this, where we've typed our payload and said it's a string. So when we combine our pipeline, if we put the modules in the wrong order and we don't get a string in, PHP will catch this for us, and we don't need to do any type checking to make sure we've got a string. So we can take advantage where possible, but there are limitations. PHP type declarations are not a universal solution for all your problems, I'm afraid. Now, I've mentioned next instruction, and it also gives us some type safety. Because it's part of your library, it's a wrapper you've written, so only modules written for your library will go on your pipeline. Everything else will get rejected because it'll be the wrong, $next will have the wrong data type. See here, I hope you can read that. This namespace here is part of our messaging pipeline. It's not part of the underlying instruction library. And we call it, and we've typed it here. So this is handy. If you've got a lot of pipelines in your project, some of them you want to be generic and you want to be able to drop them in everywhere. But in all honesty, most of the time you don't. You're building modules for a specific pipeline. The last thing you want is to get to prod and find someone shipped the wrong config and put the wrong module on the pipeline and everything's gone to pot. And you're trying to debug that. Type safety will catch that problem for you. So it's a good idea to do that. Now, I have been banging on this drum. I have not finished banging on this drum yet. Did you notice how many runtime checks are in the code that you've seen? Checks like these. We're checking that we've got a valid hash algorithm. We're checking that our config array has the entries we're expecting. The reason for this is the fundamental problem and limitation of any strict typing. How many of you do input filtering and validation for your MVC style applications? And you're familiar, it's a two-step process, I hope. Okay? So input filtering, just make sure you've got a piece of data that the code will actually run against and won't crash out because it's the wrong data type. That's all it does. It makes sure you haven't got nulls. It makes sure you've got integers or strings where you're expecting them. That's all it does. But a string can contain anything. I mean, our string goes from having JSON to base 64, and it's got some encryption along the way. So the data type stays the same, but the meaning of the data inside changes. And strict typing doesn't cover your data validation whatsoever. It can't do. All it can do is say, I've got a string, so I'm not going to crash if I pass it into a string function, for example. You've got to have appropriate runtime checks, and you've still got to write your unit tests. You've still got to do it. I actually write unit tests to make sure that types get rejected. You'll see in the unit test, you'll see there's some data providers in there passing non-strings into all of these operations to see what happens. I don't assume everything works. And you'll see from some of the comments in the code, there's some surprises in there as well. But you can go and look at that online. Right, so to finish, let's talk about unit testing. The company I founded is a quality assurance practice first and foremost. So everything is about testing for me. And I've made this as easy to test as I know how to. I don't know how to make it any easier to test. In the order to write your tests, you start off with writing unit tests for your operations. Once again, they are so easy to do because there's no magic whatsoever. We've made these things as simple and as plain and straightforward and boring as possible, which means testing them is incredibly easy. Here's a real unit test. You can find that in the code. What we're just doing here is proving that calculate HMAC works. That's all we're doing. That's a very simple unit test. You can train your junior developers to write this type of simple tests. They're easy to maintain. They're easy to understand. They're small. They're specific. To test your instructions, which is the next thing you do, they're also straightforward. But the trick here is we actually instantiate a pipeline with one instruction in. It's what we do in order to run them. Because we want to make sure they work inside the pipeline. So we create our next instruction, and then we call it with our input. And then we check the output. And you see, it's just single lines to do all this stuff. There's no huge setup got to be done. Any setup work, like here, is the setup for HMAC to make sure we can actually get a HMAC value to compare. It's got nothing to do with the fact that this is an instruction in a pipeline. It's got everything to do with the work that the instruction does. Our two helpers. Now, the nice thing about those is they are very much single responsibility classes. So you don't have to write a lot of tests to do it. Here's the tests for proving you can build a pipeline. And this code is almost identical to the example code you'll find online as well. Set up our config, set up our pipeline definition, and we want to prove that we get a pipeline out with the modules in the right order. And it's just a couple of arrays. That's all we do. Really easy to do. Tell it to build the actual pipeline, and it's just a simple comparison in PHP unit. And that tells us we've got two pipelines in the right order. It's all we have to do to prove that that works. It's very simple. For next instruction, let's execute the pipeline. Let's put data in and out and prove that's what we get. And again, you just build the pipelines and run it. There's no magic here whatsoever. The consequence of this, 100% code coverage, is easy. Very easy. Also has the advantage, because we're using some underlying libraries and classes for this, is we actually don't, some of these things, PHP unit goes, there's no actual code to execute in your library. You don't even have to write unit tests. So we've reduced the amount of work you've got to do. You've only got to write unit tests for the code that's unique to this library. And you can see here, I mean, the whole library's only got 144 lines of executable code. That's what PHP unit's telling us. It's 7,500 lines with comments, but it's 144 lines of executable code. You can do that. You you can calculate for yourself. So 100% code coverage, there's no excuse for not having 100% code coverage, absolutely none with this approach. Why do I think 100% code coverage matters? This is my philosophy, and this has stood me in good stead over a career spanning 25 plus years now. Okay, now I feel old. Yes, I started before the web was around. I've been doing this a very long time. Now, I'm not going to pretend 100% code coverage guarantees no bugs. Your code could still be doing the wrong thing. You could have met the wrong business requirement. What it does is it proves your code is doing what you expect it to do. You're validating your expectations. And if it's different to the business, that's a different problem. Unit tests can't save you from that. But if you haven't got 100% code coverage, that means you're shipping code that you have not executed under test. And that code will have bugs in it as a result. Could be silly syntax errors. You can catch those with linting. But there will be mistakes in there. So 100% code coverage is the minimum you should go to. And you can download, I've got about 40, 50 open source libraries now up there alongside this. And you'll see if you look at the code coverage for those, I don't do 100%. I do 1,000%. There's normally 5 or 10 tests covering each line of code. Now all this code is available. The library we've built, it's available on GitHub. You can download it, you can put it in production today. It's production ready. The underlying library is also up there on GitHub and is ready to use as well. Thank you very much.